I got the idea implemented for quota approval voting, and it's pretty complex. Okay, so instead of having um, multiple dimensions, you just have one dimension. Like you can move voters left to right, and you can move candidates left to right, and that's the political spectrum, left to right. What you can also do is move the candidates up and down, and that changes how broad the candidates are. So here, the blue guy square is going to get really small, and then it's going to get really big, and I guess this is just, he has a position politically, but he's also a broad candidate that many people would vote for. Doesn't seem that far away. Actually, the way I implemented this, it's pretty much just multiplying your distance to the candidate. As a voter, you have a distance to the candidate, and that's usually just the left-right distance or up-down. But in this way, I multiplied by a factor, so the factor gets really big if the candidate seems really far away, and the factor is really small if the candidate is very close. So that factor is kind of like a broadness. Another aspect of this is that you can't move this anywhere but left and right. The voters, you can only move left and right. It's a little bit limiting, but it really helps. And the reason I did it is because I wanted the explanation to be very clear down here. So let's start with this. So first of all, I took all the voters, took them out of their distribution, and just put them in order. I sorted them from left to right. So each one is represented by a little block. And if the voter voted for the blue candidate, then they're in this block. Let me simplify this a little bit. Well, you can see that the blue represents voting for the blue candidate, and yellow for the yellow candidate, and so on. Red, green, and orange. So the bars are pretty useful in showing that the blue and yellow candidates have a lot of people voting for them, and then there's support for the green and the red candidates, but actually orange has third place in support. So you can see that there's more orange supporters than green supporters. And you can see that using the bars. So that's why I made these little bars. The idea of this voting method is that there's this quota, and the quota is at the bottom. The quota represents an idea that you should have an equal representation in your legislature for every person. So there's a certain amount of representation that if everybody were equal, they would get. It would be like 1 out of 1,000,000, or however many people there are that vote. So that is represented by the height of this bar, that 1 in 1,000,000 or something like that. But you could also think of it as just 1, and like if you're represented, then you have 1 unit of representation. And so the candidates, they run for seats, and in this particular example, we have 3 seats. That's why there's 3 rounds. So you have round 1, round 2, and round 3, and that's the final winners. And you can see in this model that this is an interactive explanation. So as you mouse over each of the rounds, you get different display over here. So you can see that the winners are blue, then yellow, then orange, And the way that they were chosen is that first, we just looked at this blue bar, and the blue bar had most number of votes, 98. So blue wins, has the most votes. In the second round, you say, okay, the blue candidate is 1/3 of the legislatures, 1 out of the 3 seats. So those people that voted for blue are given that 1/3 of legislature. So their quota is reduced from 1, and it's reduced by about 1/3. So that's what this quota down here represents. You have this this blue bar is up to 1/3. So these people are now represented 1/3 of the way. What do you do with this information? So if you know that some people are already represented, then you don't need to look for another person to represent them. In the case of blue, it looks like many people are being represented by blue, almost everybody. So they're splitting support. If orange were elected, there'd be a lot of people that voted for orange, but not as many, and so he's more able to give representation to those people. So the height of this bar is how much representation that the people that voted for this candidate get. And it's pretty high for orange compared to yellow or blue. So the blue voters, they now don't need representation as much as the other voters. In particular, these guys on the end here for yellow, these guys on the end don't really need all that much representation. These guys on the end have not been represented by blue. So their vote is counted just the same as it was at the beginning. 1 vote. And these people that are already represented, which is everybody that was a blue voter, their vote was already counted by about 1/3. So now their remaining vote is 2/3. So when they're voting for orange or green or red, their total amount of vote is reduced by about 1/3 because their vote was already counted. That's just the amount of their vote that was already counted. And it's a little bit, so their vote is a little bit whited out here because you don't want to count that again. You don't want to double count them for the next representative. So now we picked the next one, and yellow got 60, so now yellow gets in. You can see that yellow had the most out of any of the candidates. Yellow just had 60 rather than 11, so wins. And again, once you count the votes, you don't want to double count, so you add up the remaining votes in the quota that is allocated for each person. So here you see the quota. This remaining bit is still here for, it's 1/3 for these voters in the middle and 2/3 for these voters on the edges. So that doesn't make a lot of difference between these candidates because orange rides a little bit on that edge, but really still the person with the most votes is going to win the next round. That's orange. So orange got 3 votes. About let's see, 17 people voted here for orange, and those 17 people also voted for blue, and maybe 16 out of those 17 people voted for yellow. So those votes were already counted, and the remaining votes are 3 votes for orange. And orange is the final winner, because he has more than red or green. So that's how you figure out the most fair way to elect people in a multi-body legislature using quota approval voting. There's also some additional features here. So you can use a 2D representation, but that doesn't work really well. You can use this 1 dimension plus broadness, or you can do the strict 1 dimension and all this vertical dimension is just thrown away. You can see in this case that there's 4 winners just because there's a tie. So these 2 people got elected, but let's try to break that tie. Alright, so in this case you can see that the quota of how much vote or how much representation each person should get is just about filled up. There's a little bit remaining over here. Actually, these people didn't vote for anybody. Other thing you might want to look at is the strategy. So if voters don't have any strategy, then they might vote for nobody. But you want to give them some strategy so that they at least vote for somebody. So let's break the tie. So this is pretty good. Everybody got a candidate that they voted for. Everybody is represented by somebody. Some people are more represented. It's just, you can only fit the puzzle pieces together in a certain limited number of ways, so you can't completely fill up an equal representation for every voter. You can get pretty close. And there are other ways to do this, like STV and RRV, single transferable vote, and reweighted range voting. So that's about it. Just showing you the different options that I added. This 1 dimension plus broadness. This quota approval method. And this interactive explanation.